Hello everyone, welcome back to a series of complete DSA using Python, specially designed for GATE, data science and artificial intelligence. In this session, we will discuss about the space complexity analysis. Space complexity of a program is decided by how much main memory is consumed by that program. So let's check out this concept in more detail. Starting with the definition of the space complexity. Space complexity of a program is made up of two types of space that is consuming. First one is space taken by the program to store the input, that is the input space, and second one is space taken by the program to process the data. So extra space required by the program, that is the auxiliary space. So input space plus auxiliary space together are making the total space complexity of a code. Input space is taken to store the input, to take the input from the user, and the auxiliary space is the extra space required to process the data. Find together are known as space complexity of that code. Here is the definition of the space complexity. So space complexity of a program is the total main memory, how much main memory the program is consuming. That is the space complexity of the program. Okay. Second thing you can note over here is that space complexity is made up of auxiliary space, that is the extra space to process the data, and the input space which is used for storing the user input. So together they are making the space complexity. That's it. This is all about the space complexity. Let's try to understand it in more detail by taking some practice questions. So let's start with our first practice question and try to find out the space complexity of that. So it's better idea that you pause this video and try this example first yourself. Try to find out what is the space complexity of this code. Otherwise I'm trying it at my end. So here this code is actually finding the factorial of a number. So we are providing a number and that is finding the factorial of that. So what is the factorial of, let's suppose 5? 5 factorial is 5 into 4 into 3 into 2 into 1. That is the factorial of 5. So what is the space complexity of this code? Let me go through the definition. Space complexity of any program is the input space plus the auxiliary space. That's it. And what is the input space required over here? See, this is the input we are taking. We are taking one variable. We are taking one variable as an input, one integer variable. So one variable means one integer variable means 4 bytes for input, and after that to find the factorial we are using two extra variable here, res and I, two extra variables we are using. That is the extra space required to process the data, that is the auxiliary space. So plus 8 byte. So we are assuming that one integer is taking 4 bytes to store, and here we have two integer. So together that is 8 bytes. Total space is 12 bytes and 12 is constant. So we can say that the space complexity of this code is order of 1. That is order of 1. Fine. So here is the same thing. Space complexity of this code is order of 1. Time complexity is n, because this loop is executing n time, approximately n time. So this is the space complexity of simple this loop based code. Now let's check out the space complexity of recursive code. This is the second example we have with us, and the same thing you can do for better learning. You can pause the video and you can try it yourself. Otherwise I'm trying it at my end. So the same code, same means we are finding the factorial of a number here also, but by using the recursion. By using the recursion, we are finding the factorial of a number. So please note down, whenever we use the recursion, CPU maintain a stack. CPU maintain a stack in main memory to keep the record of previous functions. So for example, if you are finding the factorial of 5 and value is 5. So to find the factorial of 5, you need to call this function for factorial of 4. 5 minus 1, 4. Then you will find the factorial of 4. To find the factorial of 4, you will find the factorial of 3 and so on. 2, 1. So all the previous functions will go inside the stack like this. So this is the stack. Initially you call the factorial function with the 5 value, let's suppose n value is 5, and to find the factorial of 5 you need to find the factorial of 4. So this function will be called with the for the 4 value. This function will go inside the stack. Okay, CPU is taking care of all that stuff. We as a programmer is not doing anything over here. This stack is maintained by the CPU to keep record of previous functions. So factorial of 5 will go inside the stack, then factorial of 4 will go inside the stack, then factorial of 3, 2, 1, all these previous function will go inside the stack, because we need to come back and we need to complete these functions. After when we will come to the 0 actually, then we will return back from here. This one we will return back. Then we will keep taking out all these functions out of this stack and keep processing them. So this is the extra space required to perform this recursion actually, and this stack space is taken by the CPU. Programmer do not need to worry. Okay, so the total space required here is, you can see 1, 2, 3, 4, 5. 5 information you are storing inside this stack, which is actually the n value. So the total space required for this recursive code is order of n. Due to this extra space, this is the extra space, this is the auxiliary space, this is not the input space. Okay, so if I write the space complexity of this code, so that is the input space plus the auxiliary space. Input space is nothing, just one integer, 4 byte. Okay, how much byte integer is taking, that also depend upon compiler to compiler. So we are assuming that okay, one integer is taking 4 bytes. Auxiliary space is n to maintain this stack. CPU is maintaining the stack. We are not bothered about this stack. Okay, so total space is constant plus n, that is n only. So this code will take order of n space to execute. Yes, the space complexity is order of n. Time complexity is same, but space complexity increase in case of recursion. Fine. Okay, now let me erase this screen and move on. Oh, that's it for this session. We will meet back in the next class, and don't forget to like and subscribe the channel.